Okay, so today, being the awesome person that I am, I'm totally going to do your home learning for you. Okay, but instead of doing the actual questions I've given you, I'm going to make up some of my own. So the first one is I'm going to solve x plus 7 equals 30. And you, being the smart people that you are immediately going to say, but miss, x equals 23, hello. However, it gets harder than this very quickly. So what we need to do is find a systematic way of finding x no matter how difficult the equation is. So the thing about the equal sign is that both sides of the sign have to have the same value. So that means what I have to do in reality is if I do something to one side, I have to do it to the other side as well. Otherwise, the sides are no longer equal. So what's happened to x? In this situation, to get x by itself and work out what it actually is, it's had 7 added to it. So to get x by itself, I'm going to do the reverse of that, which is minus 7. But to make sure that both sides are equal, I'm going to have to minus 7 from both sides of my equation. So once I've done minus 7 to both sides, I've got x plus 7, take away 7, that's just x. Keep my equal sign below each other. What's 30 take away 7? 23. And you are absolutely right. Now, what if I want to check my answer? How about I substitute in x equals 23 to my original equation and check that both sides balance? So let's do that now. So let's put, instead of x, I'm going to put 23 plus 7. Does 23 plus 7 equal 30? Yes, it does, so I'm done. Awesome, let's move on. Okay, the second part of the home learning gave you some information and you have to put it in the language of maths in order to solve the equation. So 5 less than 2 of a certain number is 10 more than that number. Oh my goodness. What is the number? Okay, 5 less than 2 of a certain number. Let's call that certain number x. So we've got a sentence, a bit of the sentence that says 2 of a certain number. I've got 2 of them. So I know I've got 2x in there. And 5 less than 2 of a certain number means I've got 2 of that x and 5 less of it. So my first part of my equation says 2x minus 5. Now, 5 less than 2 of a certain number is, I'm going to interpret that is to mean equals. If something is something, it equals something. Is 10 more than that number. That number, remember, we called it x, and it says it's 10 more than that number. So that means we have to put a plus 10 at the end of it. So that's my new equation, and that's what I'm going to have to solve. So you might remember this is my strategy where I'm going to put all the x's on one side of my equation and all the numbers on the other side of the equation to solve for x. So 2x, I'm going to leave it there on the left-hand side because it's bigger. I'm actually going to get rid of the x on the right-hand side, I'm going to have to do its inverse operation, which is actually minus x. Okay, if I've got regular x, that's a positive x, so the opposite of plussing x is taking away x. So I'm going to take away x from both sides there. So let's see. Take away x, take away x. Now on the left-hand side, I've got 2x take away 1x. Remember, there's an invisible 1 in front of that x. So, which leaves me simply with just x. I haven't done anything to the minus 5, so it stays there, making sure my equal signs are underneath each other. Now on the right-hand side, I've got x take away x, which is nothing, that's gone, but I haven't done anything to the positive 10. So that stays on the right-hand side, and that equation looks a lot easier to deal with than what we had at the start. Okay, now I have a simple equation here, relatively simple. I've got x take away 5 equals 10. Now to get x by itself, which is what we want to find out what it is, I need to do the inverse operation. So I need to get rid of that minus 5. And to get rid of minus 5, how about I plus 5 to both sides? Remembering what I do to one side, I have to do to the other to make sure that both sides remain equal. That equal sign is so crucial here. So, x take away 5 plus 5. Take away 5 plus 5 is nothing, so I'm just left with x. Aha! I have just x. I'm nearly home free. And 10 plus 5 is 15. So now I think that x equals 15, but I want to just check my work. So I'm going to substitute x equals 15 into my original equation to check that both sides are equal. So my original equation is up here. So every time I see an x, I'm going to put in a 15. So 2 times x is 2 times 15 minus 5 hopefully should equal 15 plus 10. So let's just check that. Okay, and we have 2 times 15 is 30. 30 minus 5 is 25. Should equal 15 plus 10, which it does. So x equals 15 is the correct solution. Alright, that's 2 out of 3. Almost there. It's a bit more complicated, but that's only because it's got some brackets in there. So remember that if you've got a number outside a bracket or a letter outside a bracket with no multiplication, division, plus or minus outside, it actually means that there is an invisible multiplication sign, and that means that that number 3 has to be multiplied by every single thing inside the bracket. Okay, but we're going to try another strategy. You could expand the brackets, but I'm going to write down the story of what happened to x in order to undo it. So, first of all, we have x, and then 3 was taken away. So I'm just going to make some notes over here. We had x, 3 was taken away. After 3 was taken away, that whole thing, that whole expression was multiplied by 3. Okay, so to undo it and find what x is, I have to do those inverse operations in the reverse order. So multiplied by 3, the inverse operation is actually divide by 3. So that's what I'm going to do first when I undo these things to tangle up x. Then the opposite, the inverse operation of minus 3 is plus 3. So I'm going to add 3 to both sides next to find x, and then hopefully I should get back to x, and that's going to be my solution. So those little notes are going to help me in the end. Okay, here I go. So the first thing I have to do is divide 3 to both sides. So I'm going to divide by 3, divide by 3. So 15 divided by 3 is of course 5, equals, we need to make sure our equal signs are underneath each other. Now 3 times x minus 3 divided by 3, 3 divided by 3 is of course 1, and we don't need to write that 1. We can simply write that that's x minus 3. Okay, and that equation looks a whole lot easier to deal with than what we had before. So that's our divide by 3 done. Our next step is going to be plus 3 to both sides. So we're going to do plus 3 plus 3. And let's see where that takes us. So 5 plus 3 is 8. Equal sign underneath the equal sign. X plus 3 minus 3. Well, minus 3 plus 3 is nothing, so I'm just left with x. Aha! I seem to have a value for x now. So, and I can rewrite that as x equals 8. I like to have my pronumeral on the left-hand side. I'm going to now check my solution by substituting x equals 8 in my original equation, which is up here. So let's see what that does. I have 15 should hopefully equal 3 multiplied by x, which is 8, minus 3. Now, BODMAS says, brackets first, 8 minus 3 is 5. So 15 should hopefully equal 3 times 5, which it does. 15 certainly does equal 15. Okay. What happens if you get two different numbers? You might have to check you've done something interesting in your working, but that's how you know it's a really good check. So we know that x equals 8 is the correct solution. And that's it. We are done.